Unit 2 is all on polynomials. We are going to become human graphing calculators, so we don't need our graphing calculators because we're going to do it ourselves. Okay, so no graphing calculators because we are going to be that graphing calculator. Now I'd like to say something right now and get it out of the way. Some of the stuff that we are doing, you've done before. By the end of this day one, we will be doing it the way that some of you are going to be like, hey, Mr. Messer, can't we just do this? The answer is yes, we can, but we'll get there. So just like stay with me as we go through these notes. And by the time we flip to the last page, like we will be doing what you guys want to do. You guys got me? So just stay with me. Thank you. Cool. What is a polynomial? Numbers times x to powers. Okay? Numbers times x to a power plus number times x to a less power. Powers have to be whole numbers. They can't be fractions. Can't be negative powers. They have to be positive powers. This is not a polynomial because this is not a positive whole number power. We will not look at this graph. We cannot have x's in the denominator. This is a rational function. We will be looking at this function, but not right now, so skip it. We are not allowed to have fractional powers. It's not a polynomial if it's a fractional power. So we are not going to look like that. We will be looking at imaginary numbers, but polynomials do not have imaginary coefficients. If you ever see a I, it is not a polynomial. We will not be looking at this. These are the polynomials we will be looking at. X to the powers times numbers, x to the powers times numbers, x to the powers times numbers. The rest of this pages is all x to the powers times numbers. And step one of becoming a human graphing calculator is find the zeros. Now, if I ask you to find the zero, what is the first thing you should do? Tell your neighbors. Ah, I like that answer. Set it equal to 0. A lot of you are like, oh, factor. It's like, oh, wait. Make sure we understand we're finding when is the y coordinate 0. Okay? I'll do the one on the left, you guys do the one on the right. Sometimes we'll just have to factor out a greatest common factor. The largest thing, again, we talked about this in unit 0, which is like, I'm glad we did unit 0 the way we did, because it's really helping you out for this unit. Find the largest term that can be divided out, undistributing. Factoring is reverse distributing. So it's dividing. What can you divide out of both terms? Maybe a positive 3, maybe a negative 3. It's up to you. X squared, I'll get negative 3x plus 4. Great. Since x is factored out, x could equal 0. Because we remember products equaling 0, as long as one piece of our product equals 0, everything's equal to 0. Here, we've done this last in unit 0, so I'm not going to spend time subtracting 4 and divided by negative 3, setting that equal to 0. We get x equals 4/3. No, positive 4/3. Negative 3x plus 4, I guess I do have to spend the time. So could equal 0, subtract 4, you get negative 3x equals negative 4, you divide by negative 3, you get x equals positive 4/3. That's how I got the positive 4/3. Quick little heads up. If it was 9x plus 12, and you factored out a 3, if you have something outside a factored form, it doesn't mean 0 is a solution. Having this 3 here does not mean x equals 0 is a solution. We talked about this in unit 0. Now, typically, we will be factoring out amounts of x's, not just numbers. So we will be getting this x equals 0 a lot in this unit. But remember, in unit 0, we rarely had x equals 0 because we factored out the greatest common factor that could have been just a number. If a number is factored out, that does not mean 0 is a factor. We all cool with that? All right, do this one. Okay. Check with your neighbors. Okay, so don't show them the answers. Good. Probably 4x cubed, 4x plus 3. X equals 0 comes from that x. X equals negative 3/4 comes from this that equal to 0. Next. After we factor out a greatest common factor, we might have something that can be factored left over. The rest of them will be like that. Here, we have a difference of squares. Now, we could stop here and say that my answers are x equals 0 and positive and negative 3. But I would like you to actually factor this. Think of there being 0 x's. Remember that x squared plus amounts of x's plus numbers can look like x plus something times x plus something. What are the two numbers that will multiply after distributing everything to get negative 9, but add to get 0? Negative 3, positive 3. This is a difference of squares. You could simply go straight from x squared minus 9 to x plus 3 times x minus 3 if you just like square root both of them. Now, this gives us x equals 0. This gives us x equals 3. And this gives us x equals negative 3. Great. You guys do this one on the right. Any of you are working ahead? Just make sure before you work ahead, you can help those who are not ahead, okay? Some people are with me, some people are ahead. Cool. Now, heads up. Whenever we have x squared left over, it will be helpful. It will be helpful to make sure that's a positive x squared. So if I'm factoring, I want to make sure my first term ends up being a positive. So I'm not going to factor out a positive 2x cubed. No, I could. I'll instead factor out a negative 2x cubed, giving me x plus 5x minus 5, 0, negative 5, 5. Next one, we might factor out a greatest common factor here, 4x, x squared minus 3x minus 18 times 4 is negative 72. And then factor this quadratic with a equaling 1. We attempt to find the two numbers that will multiply to get negative 18, but add to get negative 3 because we understand distribution and how that works out. It'd be x times x, x squared, x times this number, an amount of x's, this number times x, an amount of x's, You'll add those amounts of x's together. The number times the number will be the last thing. That's how I remember, like that negative 18, those two numbers have to multiply to get negative 18. So I get negative 6 and positive 3. Again, we're finding these zeros, so I should have this equal to 0 everywhere. Caballero, come back over here. The block will move a chair over here. Get x equals 0, 6, and negative 3. Okay, do the one on the right.
Did you say so?
As you can tell already, this is very much like unit 0. So, good to know. 4. Two numbers that multiply to get 9 and add to get negative 6 or negative 3 and negative 3. Hey, I'm going to actually write this as x cubed times x minus 3 squared. Now, what we've seen a couple times are solutions that kind of show up multiple times. I saw a couple people say x equals 3 had a multiplicity of 2. They just wrote that down. I saw a couple people say x equals 3 was a double root. All good. All good. Just pump the brakes a little bit. We'll get there. Trust me. Got it? Okay. Factoring out a greatest common factor followed by a quadratic a does not equal 1. Quick little review. Nope, that doesn't work. 2x. I'm plugging out negative 2x so that I get a positive 2x squared. So many different ways to factor 2x squared minus 5x minus 12. For my on-level algebra 2ers who are in this class, I got your back. We multiply a by c. Find two numbers that multiply to get that and add to get b. Once we find those two numbers, break out your friend the box. Out of a row or a column, factor something out. Okay, out of this column, I'm going to factor out an x. All right, the rest is just multiplication. X times what is 2x squared? 2x. 2x times what is negative 8x? Negative 4. Negative 4 times what is negative 12? 3. 3 times x is 3x. Yeah, it works out. Yo, if you were in on-level algebra 2, this is how you learn how to factor. So you will get x equals 0, x equals 4, and x equals negative 3 halves. Go to lunch, because troop x is already there. And we'll see all of you after lunch, I'm sure of it. All right. I don't know how you want to factor this, but this is like an epitome of an easy one to factor. Because you know the last term has to be 1 and 1. Like you get 1. So it's like 1 times 1 has to be 1. So it's like, how can I get 6 x's and 9x squared? Well, it's either 9x and x gives me 9x squared, but that's not going to give me 6 x's. 3x and 3x. Like sometimes techniques help. Sometimes techniques just slow us down. Now I'm probably writing this as negative 3x squared times 3x plus 1 squared. And I'm writing x equals 0 and x equals negative a third. Cool. Hey, heads up. We are not responsible for factoring 4-term polynomials. You remember in Algebra 2, we had these 4 terms, and you'd like group, and you would like factor, and then you'd probably have to factor some more. We don't have to do it. Heads up. Difference in sum of cubes. You guys remember factoring x cubed minus 8? Remember SOAP? Everybody remember SOAP? The SOAPs? Same, opposite, always positive? Yeah, you don't have to worry about that either. Okay? Keep it simple, keep it basic. We're trying to make things as straightforward as possible. This is not coming from me. This is not coming from the other math teachers here. This is coming from the AP, the College Board, the curriculum writers. We don't have to worry about that. Great. Now, some of you already wrote down about multiplicity. We are going to start paying attention to multiplicity. Multiplicity is like the amount of times that zeros appear. For example, you have x squared, x minus 3 cubed, x plus 4. I could write this as x times x times x minus 3 times x minus 3 times x minus 3 times x plus 4. I could write that like that. Which means you could be like, well, I could have x equals 0 as a solution for that one. I could have x equals 0 for that one. I could have x equals 3 here, x equals 3 here, x equals 3 here, and x equals negative 4. Which means I have x equals 0, which occurs or has a multiplicity of 2. Cool? How do I write that down? So right now, I'm just going to write it down, and by the end of the lesson, we will use that information to our advantage. I get x equals 3, and it occurs 3 times. So right now, I'm just going to write it down, and in the future, we will use it. The multiplicity, how many times the 0 occurs, called a multiplicity. Okay. All right, so do the one on the right. You don't have to write down like the factors all separated. Just identify the zeros and the multiplicities. Don't just write it down for now. Don't use it. Don't use it. Just write it down for now. What are your zeros? What are your zeros? I keep forgetting. What are your zeros? And what are their multiplicities? Tell your neighbor. What's going on in here?
It's the best cold drink of all time.
Pumpkin spice ice latte? No?
No, that's chai.
Whoa.
Chai latte
Oh,
with
okay.
pumpkin cream cold.
Oh. Jeez. What was I thinking?
You mentioned we gotta get it right.
Oh. Okay. X equals 0 occurs once. X equals negative 1 occurs twice. X equals 2, we'll say, occurs or has a multiplicity of 3. X equals negative 3 has a multiplicity of 4. But right now, we're just going to write it down. In the future, we will use it. Don't use it until we get there, though, if you already know what it means. Yes, T4. I like to write that it's a multiplicity of 1. It occurs once. You see that it's an odd number, which is important. So, yes, if you want to leave that blank, it's fine. We could go back onto the previous pages and identify the multiplicities. We're going to use that examination of that, and now we're going to analyze that in the future. Okay. Changing gears from finding zeros to solving polynomial inequalities. For example, my first question I'm giving you is, when is this polynomial, which is already in factored form, greater than 0? start by identifying the zeros. Okay? Let's go ahead and start identifying the zeros. Where are the zeros? Find the zero. What are the zeros, Woods? Good. 0, +4 twice, and -2. We'd like to put M instead of multi. Go ahead and do that. Let's go ahead and put those down on a number line. -2 is going to be the furthest one to the left. Then I got 0. And then a little bit more to the right, I'm going to have 4. It's actually the spacing does not matter, but this is a number line. Okay? Just like an x-axis here. Now at these 3 points, when I plug them in, I get 0. Okay. Don't do things that you've done in the past until we get there. Okay? Don't be like, Mr. Messer, can I just do this? We'll get there. Just stay with me. You might learn something, okay? Okay. Our goal is to figure out when this is positive, okay? When we have greater than 0, first thing we're thinking is that, oh, positives. Positives are bigger than 0. Pluses are bigger than 0. You guys cool with that? That's a good start. All right. Here we go. A student found that when they plugged in 1, I'm going to put a little tiny 1 right here. And when they plugged in 1, I got 1 times 1 minus 4 squared times 1 plus 2. They thought about it. They're like, oh, that's a positive times a positive, that's a positive. And they put a tiny little plus right above 1. And they're like, hey, this is a solution because it's positive, it's greater than 0. Okay. Now, here's the question I'd like you to discuss with your neighbors. Is it possible for f of 2, or really any value between 0, and I'm sorry for 3, it should say 4. Is it possible for any value in between 0 and 4, like at 2, to be negative? Discuss that with your neighbors. Why? Now, what do you think? Why? Yeah, but why? Why? Why no? Who gives me a good reason? No, that's what I'm looking for. Why? Why no?
Because you square the only time.
No! Why no? No! That's stuff you've known already. Yeah, but why not? Why isn't 2 negative? That's what I'm looking for, team. You guys are all using stuff that you've already learned. You'd be like, oh, because we were told that, like, it bounces. It's like, I don't want to hear that yet. We're going to get there. Here's the reason why. If you go from positive to negative, you're going to have a 0 somewhere. Could I have a 0 between 0 and 4? Tell your neighbors, is there possibly a 0 somewhere between 0 and 4 so that I can change signs from positive to negative? Tell your neighbors. Why not? Guys, this is like starting over. In some of these units, like in this first semester, we start over and we relearn things. Okay? Thomas, we're relearning things, and we are slowing down. We're not jumping to, oh, yeah, because it looks like this. Slow down. No, there can't be. Because if there was, it'd be another 0, Cold Tricket. Not another 0. We already have our 3 zeros, 1, 2, 3. Okay. Our answer is no. Which brings up this concept called the test point. If you know all of your 0 locations, the signs of your polynomial must be consistent in between or outside your 0. Must be consistent in your interval. Who just said what? Cricket. Don't worry about copying it down. Come on, just pay attention. You guys don't use these anyway. They must be consistent. The signs must be consistent. Let me show you what this means. Cold Tricket, ready? I plugged in 1, and I got a positive. Cold Tricket. What must the sign be at 3? Cold Tricket, what must the sign be at 2? Yeah, because we found all the zeros, we can't change signs. Guess what? All we need is one test point. And if we know at that test point we got a certain sign, all of your signs are going to be that. Slow down. Don't go too fast. Don't say, can't we just do this, Mr. Messner? We will. Not yet. Okay. So, what we are asking you guys to do now is understand that concept. That if you have all of your zeros, and you want to know when things are positive or negative, use one test point in your interval, and you will know the sign in that interval. For example, if I want to know the signs to the right of 4, take 1 point. I'm going to write down a little teeny tiny 5, and I'm going to find the sign of 5. Now watch how I do this, guys. This is important. I do not care about the value. That's a positive when I plug in 5. When I plug in 5, 5 minus 4 squared is a positive. When I plug in 5, 5 plus 2 is a positive. I don't care about the number. I'm going to write down that when I plug in 5, I got a positive times a positive times a positive. Either down here or up here. Boom. I'm going to put a big plus because I know all of the signs to the right of 4 are going to be positive. Because I know there's not another 0, Woods. Now, at -1, you plug in -1 into your function, and then give me a big plus or a big minus. And do it by plugging in -1, not because you know about multiplicities and what they mean, and a lot of you do, and a lot of you are way beyond me, but it's like, we're not there yet, we'll get there. Do it. You don't have to find the value. Watch this. -1 plug in for x is a negative. -1 minus a 4 squared is a positive. -1 plus 2 is a positive. Negative times a positive times a positive. Negative. Now we will plug in -3. -3. -3 minus 4 squared. -3 plus 2. A negative times a positive times a negative is a positive. You will be doing this for a couple of examples, all of you. And then we will start doing some things that maybe you already know of later. But guys, in the future, like in this class and in AP Calculus, you're not going to be able to use the shortcuts you already know, because we're going to have different functions like logarithms, like trig functions. It's not going to be as like, oh, just do this, okay? So test points are very, very important when you get in calculus, which is why we're doing it. Now the question is, when is my function greater than 0? Remember, greater than 0 are positives. So to answer this inequality question, I come to my sign chart, and wherever I see that big plus, that's my answer. And you write down your intervals. Write down your intervals. We are not including the zeros, which is why I did not highlight them, just the pluses. That's when we are bigger than 0. Cool. Moving on. Don't you dare jump ahead and use previous knowledge like of multiplicities yet. Please locate the zeros and use test points to find the signs of your intervals and to solve this inequality. Go. Hampton just called. Yeah, and did Monica come talk to you? Did you put in copies for quizzes?
No,
All right, she's gonna do it.
But I thought the first one was incomplete, so the questions were. Okay.
Whatever.
Fine.
We'll
What
count
did
on
we-
that. I don't know. Probably to release the student or something.
Oh, okay.
I mean, because it's like, I figure like a decreasing function, the next function is less than it. If you add the two, it's like if you add two values and add two values that are less than, it has to.
Yeah, that's what I said. It's basically, I think they're assuming it's self-evident.
Yes, and that was a tricky question, right?
Oh, yeah, that's fine.
And then also I told them that, like, I'm sorry about the increases the most, because we've been harking on average. I know, I wish.
But on the notes, you need to do this next year. We're going to have to increase and decrease.
Or like total net change, maybe, like somehow we can word it. Okay. Now, yes, I want you to understand this multiplicity too, and these multiplicities are 1. Yes, but I'm not using that yet. Not yet. Sorry. Not using that yet. I'm just putting my zeros down, and I'm using test points. For example, 4. Positive, positive, positive. Positive, positive, positive. Big, fat, positive. 1 or 2. Positive, negative, positive. Negative. Keep going, because you guys aren't done yet. Keep going. Keep going, especially if you're just watching and copying down. Keep going. Not calculator. What? Keep going. What are you copying down? Stop copying down. I want you to use a test point. No. -3 plus 2. Okay. Just tell you in the future, you end up in my or Mr. Hofbaker's calculus classes. We don't put negatives underneath. Okay? There's more information that we will be putting down underneath. So like keep your signs above. It'll help in your future. If I plugged in -1, I got a positive, negative, positive, that's a negative. If I plugged in -3, I still have a positive, but I have a negative, negative. That becomes a positive. Cool. When negatives are less than 0, negatives are less than 0, I am going to look at negatives and zeros. So if you want to write down this interval, it is all my values from -2 to 3. Do another one more for me. Please do the second one. Thank you.
One more, guy.
Make sure you write your test points nice and small. Focus on your zeros. The test points are just like tiny little values that we're testing. Tiny little test points, Bacardi. Don't get yourself confused if you're writing big numbers all over the place. Okay? Tiny little test points. We understand that if these are my zeros, we can't change from positives to negatives, or else we'd have another 0. You cool with that? Okay. So we have our zeros. All we need is what's called a test point, a value between our zeros. We will take this value and we will plug it into your function for x. We don't care about the number. Okay? So, -2 times 1. I'm going to say that is a negative. 1 minus 4 cubed. That is a negative. 1 minus 2 squared. Positive. A negative times a negative times a positive is a positive. It will be positive for every value between 0 or 2. It has to be.
It's not including 0. You have to go to kids to go.
I'll push it.
We'll find out. Plug in 3. Negative, negative, positive, positive. I plug in 5. Negative, positive, positive. Negative, positive, positive, negative. Positive times positive is a positive times negative is negative. Now, plug in -1 or -2 or -3 or -4 or -1,000 or any value to the left of 0. Write it small so that you don't get it confused. Nice tiny one. Thanks, Pan. Looks perfect. Do it. What are we waiting for? You're distracting. Stop distracting. Shh. Negative 1 minus 4 cubed, good. Negative 1 minus 2 squared, good. What do you got? Positive times a negative times a positive is? Yeah, right? Let's do 2 at a time. Okay, great. Now, don't forget, positive things are bigger than 0. I will look for my positive intervals. Heads up, guys. I don't want the 0 at 2. I want between 0 and 2 and between 2 and 4. I do not include 0. I do not include 2. I do not include 0 and 4. 4. Stop. You can do inequality notation, say x is between 0 and 2, x is between 2 and 4. Cool.
You prefer one or the other?
Don't care, you have to be able to do both.
Oh.
Now, thanks.
Do you like that x is positive between 0 and 4, but not 3?
So you can say x is between 0 and 4, but x does not equal 2. Yep. Cool. Good question. Now, let's go and look at our multiplicity and see if there's something we notice. No. All right, let's look at our multiplicities of 1. Negative 2 here, 0 here. Negative 2 here, 0 here. What happened?
Which side?
Signs changed. Doesn't mean negative, it just means my signs changed. I went from positives to negatives here, I went from negatives to positives. Let's look at our multiplicities of 2. X equals 0, x equals 2. X equals 0, x equals 2.
They're the same. Is that what you go for?
Signs do not change. Now, why is that? Let's look at our little work that we did here. Okay? X equals 0 is this factor all the way here to the left. The factor all the way to the left never changed sign. It was always the plus, 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 plus. So 0, where like to the left and to the right might make a difference, won't, because this factor will always be positive. Here, our multiplicity of 2, that was the third factor. Look at our work here. Positive, 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 positive. It doesn't flip signs depending on if I'm to the right or to the left of 2. That multiplicity of 2, no sign change. The multiplicity of 3, though, well, that was my middle factor. My middle factor switched signs to the left and right of 4, the 0. So, multiplicity of 3, we do change signs. What do we notice? Odd multiplicity, sign change. SC, sign change. Even multiplicity, no sign change. Because you're always going to have that positive factor coming out of it. Okay. Once again, guys, we're getting to where you want to go. So just give me one more page before we get there. Ready? I'll show you how to quickly fill out sign charts by first identifying zeros and multiplicity. Ready? Put down -2, 0, and 2. But where your multiplicity is 1, make sure you understand there's going to be a sign change. Where your multiplicity is 2, make sure you understand there's no sign change. Use one test point somewhere, like at 3. If I plug in 3, I like to always go to the right first using the biggest positive number. I think it's easier to work with. I get a positive, and a positive. I got a big, fat positive to the right of 2. Now, I know we got a 0 here, a 0 here, and a 0 here. All we have to do now is follow my no sign changes and my sign changes, and I can fill out the rest of the sign chart without having to do so many test points. But I could always check if I wanted to. I could always go back and be like, ooh, I'm not really sure about 1. Let me plug it in. Okay, positive, positive. Oh, yeah, positive. Okay, that works out. And boom, I can quickly fill out a sign chart, understanding multiplicities, and I can quickly fill out a sign chart with only one test point. Now, greater than 0, greater than or equal to 0, fill out the answer. Go. What's the answer? Good. Don't look.
That was his fault. Come on.
Almost 20. Nope, that's not 1. That is good. Don't erase that. That's good. You're missing something. No, keep thinking about it. Oh, close, Garber. You're missing something. Where are you? Are you here? Can you sit next to him and be able to? Okay.
I'm doing that.
What's the answer? What's the answer? Almost. Not quite. Not right. Yeah, you guys are bad at this last step. You guys are all like, oh, I know what I'm doing. But then you get the, ready? Greater than or equal to 0 are positives and 0. We should be looking at positives and zeros. You guys are all stuck over here. Sure, you're good, but don't forget to include that guy over there. What do you mean, huh? Greater than or equal to 0. Would you say 0 is greater than or equal to 0? What do you mean, I guess? Or equal to 0, right? So, x equals -2 is one location where we equal 0, and then x is bigger than or equal to 0 is the other location where we are bigger than or equal to 0. We have the point -2 and the x's from 0 to infinity. This would be the interval notation. If you want to write it using interval notation, this would be the inequality/equality notation. The point at -2 and the point to the right of 0. Okay, do this one. I am coming around and making sure everybody who I know has been zoning out does this problem right there. Move over to block. Let him do it by himself. If you understand multiplicities, you know sign changes or no sign change. Whoa. Multiplicity of 2, squaring things, will always be positive. Even multiplicity, no sign change. Squaring things, always positive. No sign change when we square things. They stay positive. Think of it that way. Even, no sign change. Always think of squaring to the fourth power. Anything to an even power will always be positive. If your multiplicity is even, you are not changing your sign. Yes, now answer the question. The multiplicity is 1. So it would have a sign change. Look at your multiplicities. Label it as no sign change or sign change. Probably the best thing to do is just label the no sign changes. Just label the no sign changes and assume all the other points are sign changes.
I missed the multiplicity on one, so I didn't reply.
We'll see.
I did it right.
One of you is wrong. You're negative, positive, positive, negative. You're positive, negative, negative, positive. Who's right? Figure it out, guys. Stop it.
Who's right?
Just take a test point.
Oh,
Go to work.
I did.
Figure it. I don't know. This is the thing. Figure out if you're wrong or not. I don't want to.
I got my point and I figured it out that it was negative, so I did it like that.
Okay. So did you, Linda?
No, I figured it out.
Here,
Wait.
minus 5.
Did you see they were all positive?
So minus 5.
Wait, no. Negative 3 times positive.
Oh, yeah.
That's not positive.
And they're close.
All right. 0 is a no sign change. 1 is a sign change. Negative 4 is a sign change. Zeros at all those locations. I'm going to start with a test point at like 5. Ready? Negative 3 times 5 squared is a negative. 5 minus 1 cubed is a positive. 5 plus 4 is a positive. My 1 all the way to the right is a negative. Just make sure you do order of operations. The squaring of the 5 comes first, then times negative 3 second. Okay? Now, sign change, no sign change, sign change. When are we bigger than or equal to 0? Fortunately, we don't have any of the crazy extra points, but keep your heads up. We are between negative 4 and 1. Now, what many of you wanted to do, skip these two, go to the end. Now, what many of you wanted to do, we can do. If you know the signs of your polynomial, you actually are already a human graphing calculator, you just don't know it. If you find your zeros, by factoring if you understand your multiplicities of your zeros, all being 1, oh, I made a mistake. My bad. Back up. If you factor correctly and you find your zeros, and you understand your multiplicity and what they mean, and you use one test point to understand the signs of your polynomial, I know this has to be positive. I will change signs at 4, making that a negative. I will not change signs at 0, keeping things negative. Then we can actually know the idea of the shape of the graph. Negative values, think of this as being the x-axis. The y-axis, don't worry about it. We don't want to care about how far up or down we go. We're just talking about general shape. Negative values hitting a 0, but doing what? You guys know this as a bounce. Bouncing off of 0. Don't change signs, just hit 0, but return from whence you came. Go through, and then boom. You are a human graphing calculator, you don't even know it. Please do the next one, go. We're on the back. I know, well, let's do this. That's where we are. You guys know of it as a bounce, but I like to call a multiplicity of 2 as being a no sign change. That's what a bounce is. Four and 3. All of these multiplicities are 1, which means they are all changing signs. We are not talking about multiplicities of 3 yet. We'll talk about that next class and how we change signs. I'm going to plug in 5. I get a negative times a positive times a positive. That's a negative. Change sign, change sign, change sign. But now I know my graph's relative shape. Positive, negative, positive, negative. Look at you. You're already a human graphing calculator. Okay? That's day 1. Later.